Hey, it's Coach Reeves. I'm here to help you go over review 5.3 to get you ready for the test, okay? First set of problems we're going to talk about is they're going to ask you to solve these rational equations. We're going to check for extraneous solutions, okay? Make sure you read your directions during the test, because one of your questions on the test is they're going to ask you to put the extraneous solution, not the good solution, but they're going to ask you to put the extraneous or the bad solution in the blank. You better know the difference, okay? And you better pay attention and read. All right, so in this case, to make our fractions disappear, to make it an easier problem to handle, we're going to multiply times the common denominator. In this case, my common denominator is going to be 2p squared. So we're going to multiply times 2p squared. This cancels and leaves me with p squared minus 6p plus 5 equals, the 2's will reduce, and the p squared over p will reduce to just a single p. 1 times p is p. The 2's will reduce. The p squared over p will reduce to a p, but I'm going to need to distribute the p into that parentheses. And this will leave me with p squared minus 4p. Okay? All right, so I'm going to try to move things to get everything on the same side of the equation. We're going to try to solve it, so what we're going to do is I'm going to say minus p squared minus p squared. But in this case, these cancel and the p squares knock each other out, okay? So what is that going to leave me? That's going to leave me with a negative 6p plus 5 equal, now I'm going to combine like terms. I have a positive 1p, a negative 4p. That's going to give me a negative 3p. I move the 6p to the other side. I'm going to add 6p. I get 5 equals 3p. I divide by 3. I divide by 3. And my answer is going to be p equals 5 over 3. I have to determine if that's a good solution or not. I have to check for extraneous solutions. I look at my denominator and I have 2p and I have 2p squared. But when I put those equal to 0, in both cases, I will find out that p cannot equal 0. And that's okay, because this is my solution. It does not match my excluded value. So I do not have any extraneous solutions. This is a good answer, okay? All right, let's try another problem. All right, so we're gonna factor, okay? We can treat this as 1 over 1 if you want, it's your decision. But we're gonna factor this denominator and we're gonna get n times n minus 1. I have an n by itself on the outside, so it turns out that this is my common denominator. I will multiply everybody times n minus 1. n minus 1. n minus 1. Okay? In this case, the n's are going to cancel. And so now I have to multiply n minus 1 times n plus 1. That you can either FOIL it or however you need to multiply, distribute. We're going to get n squared minus 1. This turns out to be the difference of 2 squares. Okay? All right, in this case, I have nothing that's going to cancel, so I just multiply that together. This came from there. So I can just put it back together. N times n is n squared n times negative 1 is a negative n. Equals, everything cancels, and I'm left with the number 5. Okay? So I'm going to move the 5 to the other side, get a 0 on one side, and then try to solve it. Okay? N squared plus n squared will leave me with 2n squared. I have a negative n, and when I move my 5, I get negative 6, and this equals 0. So I'm going to factor this into two parentheses. We know that my signs are going to be different. And because I have a coefficient of 2, I'm going to use the box method. You can use the grouping method, but we're going to factor over here. Okay? We're going to multiply 2 times negative 6. 2 times negative 6 is a negative 12. And because it's a negative number, I have to subtract to find my combinations. My possible combinations are 1 times 12, 2 times 6, and 3 times 4. We're trying to pick a combination that subtracted will give us a negative 1. So we're going to use the 3 and the 4, but we're going to make the 4 a negative and the 3 a positive. I have a 2 and an n in common. I have a 3 in common. I have an n in common. I have a negative and a 2 in common. So that means to come over here and put 2n plus 3 and n minus 2. So when we solve this, we're going to take the opposite of 3 divided by 2. The opposite of 2 is a positive 2. These are my possible solutions. I have to check and see if I have any extraneous solutions. So when I go to my denominator, I'm going to find out that n cannot be 0 and n cannot be a positive 1. So in this case, they're both good answers. We're okay. But remember what I said before we got started. You need to read the directions, okay? If they ask you for solutions, this is what you would put in the blank. But if one of those was a bad answer and they say list the extraneous solution, they're asking you to list the bad answer, that's what you put in the blank. Please read your directions, okay? All right, next problem. We need to solve the inequality. This one's a little special because we're going to have to move the 1 first. We're going to have to move it to the other side by adding 1. So we're going to look at negative 3x plus 17 over 2x minus 12. I'm going to add 1, and this is going to be less than or equal to 0. Okay? So we're going to make that 1, I'm going to make this 1 a fraction. We're going to make this 1 over 1. I need to get a common denominator. My common denominator is 2x minus 12. So we multiply the bottom times 2x minus 12. We're going to multiply the top times 2x minus 12. Whenever you have the same thing over itself, it is equal to the number 1. So we're okay. But we're going to combine like terms. I have a negative 3x. I have a positive 2x, which is going to leave me with a negative x. I have a positive 17 minus 12, which leaves me with a positive 5. Over 2x minus 12. And this is going to be less than or equal to 0. Okay? So far, so good. We're going to factor the denominator. Okay? This is going to be 2 parentheses x x minus 6. Now we can determine what numbers to put on our number line. In this case, you set it equal to 0. You would say negative x plus 5 equals 0. You move the x to the other side, and you're going to get 5 equals a positive x. So we're going to have a 5 on our number line. On this case, we have to put the x minus 6 equal to 0. We're going to move the 6, and we're going to get x equals 6. So we're just going to space this. Let's respace this. We'll put a 5 here, and we're going to put a 6 here. That's what's on our number line. We need to pick a number to substitute in. We're going to pick the number 0. Turns out that the number 0 is going to be in this outside zone. The number 0 is in your outside zone, so we're going to substitute it in. 0 plus 5 is 5. 2 times 0, 0 minus 12 is a negative 12. Is this negative number less than 0? The answer is yes. Okay? So this makes this is a true, makes this false, makes this true. Okay? Now be careful. You have a bar underneath your inequality symbol, or you have an or equal to. Okay? That means you're thinking about putting in closed circles. But anything that comes from the denominator, the 6 came from the denominator, anything that comes from the denominator has to have an open circle, because the denominator can never equal 0. So this is going to be a closed circle. This is going to be an open circle. Okay? So when we write our answer, let's give us some room here. When we write our answer, the good stuff is going to be from here to negative infinity and from here to positive infinity. So we'll write it as negative infinity to 5, right? And then we're going to go 6 to positive infinity. You okay with that? All right? Let's try another one. We're going to factor the top, okay? So we're going to factor this, and this is going to factor into, signs are different, so we're going to go a plus and a minus. We're going to have x's. In this case, we're going to use 6 times 8, all right? But we're going to put the 8 with the plus sign because the 2 is positive, and we have the x plus 5. So now we're ready to determine what numbers to put on the number line. Okay? This is going to give us a negative 8. This is going to give us a positive 6. This is going to give us a negative 5. So we're going to put a negative 8 on the number line, a negative 5 on the number line, and a positive 6 on our number line. Okay? This has a bar underneath, so we're thinking closed circles except for the negative 5. This has to be open because it's coming from the denominator. So, closed circle, open circle, closed circle. Because the bar underneath, we're going to use closed circles except for anything that comes from the denominator. It always gets an open circle. Okay? We're going to pick the number 0. The number 0 is in this zone. Let's go ahead and make our zones if that helps you. But the number 0, let's change colors. The number 0 is in this zone right here between negative 5 and 6. So we're going to substitute it in. I always think it's easier to go back to the original equation. 0 squared is 0. 2 times 0 is 0, which leaves us with a negative 48. 5 is 5. Greater than 0. Is this negative fraction greater than 0? No, this is not a true statement. So that means this zone is bad. That means they alternate. This is going to be good. This will be good. This will be bad. So anything in here is a good solution. Anything from here to infinity is also a good solution. So we're going to write it in interval notation. We're going to go from -8, this is a hard bracket. We have a closed circle. Be careful and slow down. But you have a closed circle, so you're going to get a hard bracket of -8 to -5, soft bracket. Put our U, hard bracket, 6 to infinity. Okay? All right, good. Let's keep rolling. All right, so now we're going to graph our rational equation. Okay? To do this, we're going to need to factor. So we're going to factor the top, and we're going to get 2 parentheses. We're going to say the signs are the same. We're going to get, let's change it up. We're going to get x's. And in this case, we're going to use 2 times 4 to get to the 8. In the denominator, we have a greatest common factor of 3. We're going to factor out our 3. We're going to get x squared plus 5x plus 4. We're going to keep factoring. We're going to have 3. We're going to go to 2 parentheses. We know our signs are going to be the same. And we're going to break this down into x and x and 1 and 4. Now, we took up some space for our domain, but there's our factored form. We need to find the value of the domain before we do anything else, okay? So, because we're out of space, I'm going to move this up here. We're going to say 3, this is my denominator, 3 x plus 1, x plus 4. Okay? And then we have x plus 2, x plus 4. Okay, there we go. All right, so we're going to erase this because it's in the way. My domain. How do you find your domain? You find your domain by setting these factors in the denominator equal to 0. So we're going to say x plus 1 equals 0, x plus 4 equals 0. We move the 1 and get x equals a -1. We slash it. We move the 4 and we get x equals a -4, and then you say no. These are our restrictions. This is what our limits to our domain, okay? It cannot be a -1. It cannot be a -4. So how do we write this in interval notation? We're going to go from -infinity to -4. Close it with a soft bracket because we cannot touch it, cannot include it. Have a U. We're going to go -4 to -1. We're going to close it. We're going to have a U. We're going to open it. And we're going to go from -1 to positive infinity. This is how we're going to write our domain. Okay? You always find your domain before you reduce. It's the only thing that we find before we reduce, but you need to find your domain before you reduce. Okay? So, let me get over here. Get rid of some of this stuff. Okay, now, the next thing we want to talk about is, do we have a hole? How do you know if you have a hole? Well, if you have something that will cancel, in this case we had x plus 1, x plus 4. Yes, we have something that would cancel. Our x plus 4s will cancel. Since those cancel, we have terms that cancel, we will have a whole. So we're going to take what is remaining after we reduce. We're going to have y equals x plus 2 over 3 times x plus 1. That's what we have left. Now the rule is to determine where the location of the whole goes, you take the part that canceled and you set it equal to 0. So we're going to take the x plus 4 and we're going to set it equal to 0. We're going to move the 4 and we get x equals negative 4. There is half of the location of the whole. Our whole will be at negative 4, comma, something. We have to find our y value. To find your y value, you're going to substitute that negative 4 to wherever you see an x, okay? So we're going to substitute this, and we're going to put negative 4 here. Negative 4 plus 2 is a negative 2. We're going to put negative 4 here. And negative 4 plus 1 is a negative 3. 3 times negative 3 is a negative 9. The negatives cancel, and that's going to leave me with a positive 2 over 9. Okay? So we're going to go over here to our graph, and at negative 4 to positive 2 over 9, we're going to have something that looks like this, a little hole about right there. Okay? Good? All right, so next thing we want to do is we want to find our vertical asymptote. So let me erase some of this stuff. I'm going to go back to my original, or what's left after we reduce. I'm going to have y equals x plus 2 over 3 x plus 1. Don't forget where we are. To find my vertical asymptote, we're going to take the reduced part and we're going to set that factor equal to 0. We're going to say x plus 1 equal to 0. We're going to move the 1 and we're going to get x equals a negative 1. So now that is my vertical asymptote of x equals negative 1. So we're going to ask you to come over here to graph it, and x equals negative 1. Let me make it a little straighter. Oh, that's not very good. There's my vertical asymptote. Okay. Next thing we want to do is we want to find our horizontal asymptote. Let me move this. Okay. Our horizontal asymptote. To find our horizontal asymptote, this is where we use Bobo Botten eats DC. Okay? Look at my problem. The exponent on that top variable is 1. The exponent on the bottom variable is 1. So this is the exponents are the same. That's an eats DC. So we're going to divide the front coefficient. There is an invisible 1 sitting right here. So when we divide our coefficients, we're going to find out that y equals 1/3. So we're going to draw a line over here at 1/3. It's a little higher. It's harder with there to have fractions, but there's my horizontal asymptote. Okay, that's 1/3. Okay, this is going to be tough to see because it's the hole is a little bit lower than your horizontal asymptote. To find your y-intercept, we're going to ask you to substitute a 0 where the x's are. We're going to ask you to substitute a 0 here. 0 plus 2 is 2. We're going to ask you to substitute a 0 here. 0 plus 1 is 1. 1 times 3 is 3. So my y-intercept is going to be at 0 and 2. 2/3. There's your y-intercept. So we're going to touch it 0 and 2/3. Right above that, just above your horizontal asymptote, which is at 1/3. Okay? Now to find my x-intercept. To find our x-intercept, let me rewrite this because it's a little busy. Y equals x plus 2 over 3x plus 1. Okay, if you look at your notes, remember, to find the x-intercept, we're going to ask you to set the numerator equal to 0. And when you move the 2 to the other side, you're going to subtract 2. Okay, you're going to subtract 2, and you're going to get x, or -2 equals x. So this is going to give you -2, 0. There's your x-intercept. Right there. Okay? And then to actually finish this out, to find some points, we would ask you to graph this. Okay? So if you go to your calculator, x plus 2 over 3x plus 1. Okay, we graph this. I would suggest you use parentheses, but it's okay, your choice. All right, so we're going to say parentheses, x plus 2, close it, divide, parentheses, 3, another parentheses, x plus 1, enter. Now, check your calculator to make sure it looks like what you have on your paper. Okay? All right, so now we go to Control T. And you can find some points that are on your graph. You can pick what you need as far as that goes. Okay? This is the easy part. You can pick points off of your table just as easily as I can. And then you go back to your graph, and then you're going to connect your dots. You're going to say, okay, my graph is going to be through here. And if you saw that, my graph is going to go through here. Okay? Good enough? Good enough. All right, next situation. What are we going to go to? Horizontal asymptotes. Now, we just talked about this, but we haven't talked about one with the constant added or subtracted at the very end. I want you to focus right here. I want you to focus on the fraction portion. Determine your horizontal asymptote, and then once you get a number value, you either add or do whatever it asks you to do at the back end, add or subtract depending on the problem. In this case, my exponents are the same. My exponents are the same, so we will divide the coefficients, and that would give me 3 over 1. This will give me a 3. But this says to add 1. So in this case, my horizontal asymptote will be y equals 4. Use the fraction to determine the initial horizontal asymptote, and then you may have to add or subtract to that value. Okay? This is like the last two. No, this is actually 21 and 22 maybe, or something like that on your review sheet. We're almost done. A little bit more. We're going to write some equations. Okay? And if you remember, I gave you a little helpful chart or an example diagram. It said y equals, we had our fraction bar. We said we were going to put the x-intercept at the top. We're going to say we're going to put the vertical asymptote at the bottom. We said we would include the holes at the top and the bottom. And then we would say also we would consider our horizontal asymptote if we need to. Okay? Excuse me. Okay, so we're going to start off with an equation. Y equals. And then so we start reading. There is a 0 at 2. A 0 is the same thing as the x-intercept. The x-intercept goes in the numerator. And to put this back into parentheses, we're going to take the opposite, which would be x minus 2. It says that we have a whole at x equals negative 3. Okay? So in our notes, we told you that when we have a whole, that we're only going to focus on the x value. All right? Now, where does the whole go? It goes to the numerator and the denominator. So put it in parentheses. We're going to take the opposite, and that's going to be x plus 3, x plus 3. The next thing we come to is the vertical asymptote. It has a vertical asymptote equal to 5. The vertical asymptote goes into the denominator. So to put it back into parentheses, we're going to take the opposite. The opposite would be x minus 5. And it says, and the horizontal asymptote is 1. So that means it's not 0. There is a horizontal asymptote, but my horizontal asymptote is 1, which means we probably have 1 divided by 1. So in this case, if I wanted to look at it, this is going to give me, let me bring this up just a little bit. If you really wanted to look at this, you're looking at x squared, because x times x is x squared. X times x is x squared, but you're going to have a 1 in front, so 1 divided by 1 is 1. I don't need to make any changes to this. This would be my equation. Now remember, some teachers would make you FOIL this back together. We're worried about your time. We're not going to make you do that last step. We're going to let you leave it as a factored form. Okay? All right, let's keep going. How do you write an equation if I have just a graph? Same thing. We're going to go y equals, we're going to put our line. The first thing I want to talk about is the x-intercept. Where does my graph touch the x-axis? My graph touches the x-axis right there at a positive 1. X-intercept goes in the numerator. We take the opposite of a positive 1 and we're going to write x minus 1. Okay? Also in this case, we're going to find our vertical asymptote. Okay? My vertical asymptote is right here at negative 1. Vertical asymptote goes in the denominator. So we're going to take the opposite, and that's going to be x plus 1. Does my graph have a hole? Yes, it does. And when it has a hole, we only focus on the x value. The x value is a positive 2. We're right here on this hole. The x value is at a positive 2. So we're going to put that back into parentheses. We're going to take the opposite, and that's going to give me x minus 2 at the top and x minus 2 at the bottom. Okay? Now, we've already looked at everything else except now we look at the horizontal asymptote. Where is my horizontal asymptote? It's right here, and it crosses at negative 3. That's where it is. My horizontal asymptote is y equals negative 3. Well, it's not 0, meaning the bigger exponent is at the bottom. There is an asymptote, so it's not bottom. So it has to be in each DC. And we need this to be a negative 3, which is equivalent to negative 3 over 1. So we're going to put a negative 3 in the front of our parentheses. And this would be your equation. Okay? All right, so we've talked about a lot. You know, hopefully you've been doing your homework, you've been watching videos, you've been practicing. Here's the thing. You need to keep practicing. Okay? That way, if you get stuck, you got to tell us where you're stuck so we can help you, we can get you unstuck and make sure you're successful on your test. All right? Do your review sheet and let us know where you need help. Good luck.